All right, well, thanks for joining me today as we want to review some of the aspects of stored fuel and the treatments that are available to solve some of the problems that are associated with stored fuels. I am Eric Bjornstad. I'm the Technical Information Director here at Bell Performance. And at the end of our time today, our main objective is going to be for you to have a significantly better understanding of the important aspects of treating stored fuels and the options that Bell Performance has available to do so. And so today we're going to touch on the main problems that stored fuels have and the solutions that Bell Performance offers to address those problems, namely fuel stabilizers, water controllers, anti-corrosion treatments, and sludge and biomass dispersants. Now, one thing we will not address in our time here today are biocides. The topic of biocides has a lot of detail associated with it, and it has so much so that we have dedicated its own training presentations specific to biocides so that we can cover that, and give it its proper due, so to speak. So we're also going to talk about how these different things, these different treatment options work from a chemistry standpoint. We want to talk about what are some of the fuel problems that are addressed and solved by each kind of treatment. We want to talk about how you use them so that their effectiveness is maximized. And then lastly, we'll try to relate as much of this as possible with market-specific information. Who are the market users that should get the most benefit from these kinds of solutions, and what are the specific benefits that those market sectors are going to experience? So to kick this off, let's dive into the big problem of fuel instability and talk about the fuel stabilization solutions that are available to address that problem. Now, there is an implicit expectation that stored fuel is going to do what's expected of it at any time in its life. In fact, stored fuel entities, people who store fuel for a certain kind of use, they rely on this implicit expectation as an integral part of doing their business. So, for example, you would have emergency backup systems for like a hospital and healthcare facilities. These emergency backup systems rely on stored fuel to help them execute critical functions like run emergency power systems. And if those systems fail because of fuel stability problems, then that is a huge potential issue for them. And every time that there's a major hurricane, we see this problem manifested in real life, like with Superstorm Sandy that hit the Northeast, and Hurricane Katrina that hit, of course, the Gulf Coast of the United States. And so the potential for this not happening, the potential for their emergency systems not working properly, this creates budget uncertainty for business. Are they going to have to pay for unexpected problems in the future? And how can they account for, how can they budget for that possibility of that kind of thing happening? And this is a significant concern for these businesses because the costs that are associated with shutdowns and disruptions because their fuel isn't performing properly can be pretty serious. You've got, and the different kinds of costs you've got. First of all, you've got monetary costs. Everything from the money that's associated with fuel usage being raised because the fuel is going bad, higher equipment costs, critical costs for impaired emergency response, things like this. And then there are other costs that extend just beyond the monetary, non-monetary costs like the cost of the mental headaches of damage control and having to put out personnel fires. And keep in mind that these different kinds of costs are not the same for everybody. It costs some parties even more than it costs other parties. For example, if you have a critical use or an emergency backup system and something goes wrong, the costs of impaired response there are higher than the cost of an impaired response, let's say if you are a grocery store that has a backup generator that doesn't work. I mean, if you think about it, when Superstorm Sandy hit the Northeast and all those generators failed at those hospitals, how much did that end up costing all the different levels of people involved in that? Quite a lot. So the issue of fuel stability is very important on many levels for a lot of different people. It's worth very much paying attention to. Now, when we say fuel stability, what we're referring to is a fuel's ability to resist change to its properties over a period of time. Now, like many things, if you take petroleum fuel and you store it, it will become unstable if you give it enough time. And that is because it gets exposed to certain kinds of things. We'll call them environmental actors. And these environmental actors cause chemical reactions to start and then to initiate in the fuel, and these chemical reactions eventually compromise the fuel stability because it changes the fuel's composition. Now, the chemistry of diesel and gasoline fuel instability can be summarized. If we're trying to describe that, when we're talking about processes that compromise fuel stability, we're talking about chemical processes or chemistry processes. And this chemistry can be summarized as a chemical conversion of precursor molecules into species of higher molecular weight with limited solubility. See, that's the definition that you would get if you were reading a chemistry textbook. If we were explaining it to a field level person or to a customer, what we would say is that molecules in the fuel react with each other and they get changed into bigger and bigger molecules that eventually become so large and so heavy that they can't stay dissolved in the fuel and they start to drop out. And all fuel starts with a certain number of unstable molecular precursors already in the fuel. In other words, unstable molecules. And these molecules normally float around in the fuel, and because they're unstable, they are looking for something to react with in order to make themselves stable, because that's what happens in the chemistry world. Unstable molecules by nature will look to become stable, and this happens through them reacting with other molecules. Now, over time, as that fuel gets exposed to certain what we might call catalytic elements, it makes it easier for some of these molecules to start reacting either with each other or with other molecules in the fuel. And so when this happens, you get a bunch of normally stable hydrocarbon molecules in the fuel, and they get transformed. They get changed into longer, unstable precursor molecules that then start their own chain reactions that react with other molecules, and as time goes on, you get a lot of reactions happening in this fuel, and adding all the results of all those reactions together, you get a compromising of the stability of the fuel. And when this happens, typically the first thing that you will notice is that the fuel will darken and it will change color. So what are these environmental bad actors that we referred to that are responsible for driving changes to the fuel's instability? Well, there's 5 or 6 of them. First 3 here that you see. Number 1, water. Water acts as an oxygen donator for reactions, and so it contributes to both oxidation reactions and hydrolysis reactions. Plus, water is a key ingredient in the establishment of microbial problems in stored fuel, which in and of themselves can really quickly degrade fuel quality. Second actor is oxygen itself, of course. Anytime you hear about fuel being oxidized or you hear about oxidation reactions, those are reactions involving oxygen, and they are probably the primary reaction that goes on in fuel that results in its instability. Third one is metal catalysts. when the fuel gets exposed to certain kinds of metals like copper and brass and bronze, and there are a few more, but those are some of the main ones. These metals will act as catalysts to speed up and drive instability reactions. Many times you will get fuel that gets exposed to these, like for example, gets exposed to copper components in the fuel distribution system. Number 4 is heat. Heat provides energy for the chemical reactions to happen. And this makes sense because all chemical reactions need a certain amount of energy input, so to speak, in order for them to start. Some reactions need more than others. If you think about it, it makes perfect sense that chemical reactions tend to happen faster in a warm environment than a cold environment. 5th one is light. Light also provides the needed energy for these chemical reactions to happen. And then number 6 are microbes, like we said earlier. Microbes produce acids, they produce biological byproducts, and these will in and of themselves contribute to reactions in the fuel and, create a really, a hot mess, so to speak, of fuel instability going on in that stored fuel. So, you've got these bad actors, these environmental actors, that are causing the stored fuel to become unstable and form larger and heavier molecules over a period of time. These molecules, different people call them different things. Some people call them gums and varnishes. Some people call them, heavy sludge. Some people call them as, asphaltenes, which is a little bit more specific name. But because they are larger and heavier than the previously homogeneous molecules in fuel, they tend to drop out of the fuel more easily, and they sink to the bottom of the storage tank. And so if you have fuel that has a significant content of these heavier molecules, and you try to burn that fuel, you try to use that fuel in an engine, it's not going to burn or combust in quite the same way as it did when it was fresh and healthy. So what effects might you expect to see if you were trying to use unstable fuel? Well, things like what we see on the screen here. You get deposits that are formed in critical areas like injectors and combustion chambers and valves. Any place that the fuel goes where combustion is trying any place either where the fuel is being delivered, like the injectors, or where the fuel is being delivered into, which is then being burned, like combustion chambers. So you get deposit formations, you get loss of mileage and performance because of incomplete and inefficient combustion, because these heavy ends heavy end molecules that fall out of the distillate fuel, they do not combust as cleanly as pure fuel does, and so you do not get as much energy and as much mileage or as much work out of that fuel as you normally would. You also get raised emissions, higher emissions levels, because if you're burning unstable, stratified fuel and it's not completely combusting, that's going to give you, by definition, it's going to give you higher levels of carbon monoxide, higher levels of particulate matter, and unburned hydrocarbons being formed. Anytime you have higher levels of these kinds of emissions, that is always evidence of poor combustion. And for diesel engines, if you have a diesel particulate filter, then you're going to fill up your DPF faster, and so it's going to affect your service intervals. So, given these problems, how do you know exactly what state the fuel is in, and how far along it is before it might be expected to cause problems for you? How can you know this? How do you assess the condition of the fuel? Well, initially, if you have fuel that is bad, fuel that has become unstable or that is well on its way to being unstable, you can do a simple sight and smell test. You can take a fuel sample and just look at it, and its physical properties will be evidently different than it was when it was fresh and new. Fuel can appear to be darkened. It can appear to be stratified, where you have different layers of color, and that's because you have layers of larger molecules that are in the process of falling out of the fuel. Of course, if the fuel has died, it can be a little bit more challenging to recognize these, but if the fuel is far enough along, you can recognize it even in dyed fuel. However, sensory analysis is not always enough. Sometimes we need more specific answers to these questions. And so at that point, that's when we turn to qualitative and quantitative ASTM testing to help us measure and quantify the extent to which a fuel has gone bad, or to help us better be able to predict that a fuel sample is on its way there. So when we talk about ASTM tests for fuel stability, we're talking about something like a D2272 accelerated stability test. That's also known as the accelerated oxidative stability test. And it is one of two main ASTM tests that estimate the stability value of a given fuel sample. Now, for point of reference, the other one that we would talk about is accelerated thermal stability, which is a similar test. It documents the stability of distillate fuel oils at elevated temperatures. But the most important one for our purposes is oxidative stability. Oxidative stability talks about a fuel's ability to resist change in its condition as it's exposed to oxygen over a long period of time. In other words, it's a better reflection of what we're looking at with stored fuel in the real world. So in order to run this test, they take a fuel sample and they warm it up a little bit, and then they put it in a special chamber and they expose it to high levels of oxygen. Now, any molecular precursors that are already existing in the fuel, any unstable molecules, well, those will want to start reacting, and those will start to form sediments and gums and varnishes, and they will do it at an accelerated rate. When the test is finished, the technician can then isolate the sediments that have been formed, and they can calculate a stability rating for the fuel, which is a reflection of how likely that fuel is to change condition in the near future. So not only does this test quantify the fuel's current condition, but it's a great way to predict if you use a stability additive, it's a great way to show whether that has been effective. Or, better yet, if you have the fuel process, mechanically filtered, if you use a fuel polishing service or fuel filtration service, you can use this kind of test to compare the effects of that service or that chemical from before to after. And it would give you a quantified, meaningful measurement of change in the fuel's condition. So this is a very important test, so much so that it is actually specified in the D975 diesel fuel specifications. And this kind of quantitative fuel testing, it can give us a more of a clearly defined answer on the real current condition of stored fuel. So let's say that you have this information. Now it's implying that you need to do something. But what can you do about stored fuel stability? How can you keep fuel from becoming unstable? Well, the only way to keep fuel from becoming unstable is to stop the chemical reactions, or at least interrupt them in the beginning, so that the reactions never have a chance to get started. And you would do this through the application of a chemical stabilization treatment put into the fuel before these reactions started happening. Now, in the context of what Bell Performance does, when you talk about fuel stabilizer, you're talking about Dee-Zol Life. Dee-Zol Life is Bell Performance's stability treatment for diesel fuels. And it gets the job done because, as we'll discuss more in a minute, it actually contains a package of multiple types of active ingredients. It's not just one ingredient. It contains 5 or 6 different ingredients, each one designed to target one aspect or one cause, rather, of fuel instability. So it contains antioxidants, it contains metal deactivators, anti-peroxidals, dispersants, and some other things. And it contains them all in one package that effectively protects and preserves stored fuel stability at about a 1 to 2,000 base treat rate. So these different kinds of ingredients, what are they? A good stability treatment, and Dee-Zol Life is a good stability treatment, they have to have multiple components that address different elements or aspects of fuel stability. So what are these aspects? Okay, well, the first one that Dee-Zol Life contains is, or the first two that it contains rather, is what you see on your screen: antioxidants and stabilizers. Now you see antioxidants 10 to 80 ppm. What that means is that any good stabilizer package will need to deliver that amount of antioxidant into the fuel. There are plenty of things that masquerade as stability treatments that don't have anywhere near the amount of active ingredients necessary to accomplish any of these things. So an antioxidant, what an antioxidant does is it interrupts or negates oxidation reactions. It interrupts the reaction of oxygen that can be contained in dissolved air that goes into the fuel and interacts with reactive compounds in the fuel, and you start getting these antioxidant reactions, which are a primary driver of fuel instability. So an antioxidant interrupts, stops that. Second, we call this stabilizer. Now, of course, we're calling the whole thing stabilizer, so you may think we're being redundant. What we really mean is we're really referring to something that neutralizes acid-base reactions. So maybe you call it an acid-base stabilizer, or whatever you want. But it neutralizes those kinds of reactions and actually causes them to form non-reactive products. And that's important because if it's a non-reactive byproduct of the acid-base reaction, then that means it can't carry on any kind of chain reaction. And that's what you want. Third one is metal deactivators. Metal deactivators are important to have because, like we said earlier, many times fuel will be exposed to catalytic metals. We said copper before we said brass. There's also iron can be a catalytic metal as well. So you have a small amount of metal deactivator in there. And they tie up these metals. Sometimes you'll hear the term chelate or chelate, C-H-E-L-A-T-E, and that's what that means. Metal deactivators chelate these metals. They neutralize their catalytic effect so that they can't speed up instability reactions. Fourth component are dispersants. Now, a dispersant is an important thing to have, but a dispersant in and of itself does not prevent or neutralize chemical reactions in the fuel like some of these other things do. What it does is it takes the particulates that are formed by these other reactions, and it actually acts upon them, and it actually keeps them separated from each other or keeps them dispersed in the fuel. If they can't come into contact with each other, they have less of a chance of agglomerating or clustering or growing, sticking together, growing larger and larger over time. They have less of a chance to do that. And so what that does effectively is it slows that process down, which means the fuel essentially has a longer stability life, so to speak. So dispersants, fourth element of a stability package that's important to have. Fifth one are corrosion inhibitors. Most petroleum pipes and tanks are made of steel. So the most common corrosion that you would have when stored fuel moves or is housed in this system, the most common corrosion you'd have is the formation of rust because of the presence of water. Now, over time, severe rusting can eat holes in steel walls in the tank, which, of course, creates leaks, which is a big problem for the tank owner. But more immediately, the fuel itself can get contaminated with rust particles. And then those rust particles can plug fuel filters or they can increase wear on the injectors and the fuel pumps. So a corrosion inhibitor is a great thing to have in a stability package because it attaches to metal surfaces chemically and it forms a barrier that then prevents attack from outside corrosive agents. And a good corrosion inhibitor typically will be in a stability package in about a 5 to 15 ppm effective treat rate. So, bottom line here is that a good stability package like Dee-Zol Life will contain all of these kinds of active ingredients for the broadest possible spectrum of preventive benefit. Now, like I was beginning to say earlier, there are many products out there that claim to have stability benefits, and they always claim them as part of some kind of multifunction package. And many times these these proposed multifunctions have really, really low treat rates. Some of them talk about that they can do a bunch of different things at a 1 to 10,000, or like you see here, 1 to 80 gallons, or a 1 to 20,000 gallons, or something like that. And you can always take that kind of thing as a grain of salt, so to speak, or I should say with a grain of salt, because if you take all of the things that it claims to do, and you add up the required concentrations of the individual components that you would need in order to do, the 4, 5, 6, 7, 8 things that a given product says it can do, if you add all those up, then you get a better idea of how much of the minimum amount of formula space that you need to have in order to have a multifunction product that actually does, what they're talking about. So if you have let's say you have a product that claims to do 7 different things, and it claims to do it at a 1 to 10,000 treat rate. 1 to 10,000 treat rate is equivalent to 100 parts per million, or, in American, it's 1 ounce to 80 gallons. If you had that kind of thing, it's highly, highly unlikely that it would have enough active ingredients in it to do just about anything that it claims, especially if it says stability. Typically, you would need at least 80 to 100 parts per million of stabilizer alone, which means it would need to be 100% stabilizer package. And if it's claiming to do 6 other things as well, you can see the problem with that. So when you're choosing, you already know that you need to have a fuel stability treatment. When you're choosing which one to use, it's important to keep this kind of stuff in mind. So when we're talking about Dee-Zol Life, the stability treatment from Bell Performance, what are some of the common questions that people might have about Dee-Zol Life when they're trying to figure out if it's right for them? Well, the first question that someone might ask is, how long will it extend stored fuel life? And that is definitely a fair question. It's one that gets asked all the time, and it's one you would expect to hear, because commonly it'd be something like, if I used a stabilizer, how long would it stabilize my fuel, or how much longer would it extend the life? People want to know what to expect, so it's definitely fair to ask that. And the answer to that is it depends, which is not a very satisfying answer for a lot of people, but you have to explain a couple things when you're considering this. In reality, there is no one answer to this question that is completely right for all situations, because there are differences both in fuel composition and in environmental and storage conditions that have a meaningful impact on the fuel's baseline storage life. No 2 fuel samples from different feedstock streams are exactly the same in composition, and that means if they're not the same in composition, one may have more precursors to start with than the other. And then no 2 storage conditions are exactly the same from day to day, week to week, and from place to place. And storage conditions definitely have an influence on storage life. But that being said, you still have to give an answer, right? Because just saying it depends doesn't help someone make a decision as to whether this is right for them. So what we say is, in most fuel samples, you can get at least double the storage life. Now, we say double. We don't say, 2 years or a specific amount of time, because we don't know what the fuel was starting at, so to speak. So this allows us to be able to take that into account. So the answer that we would give when someone asks, how long can Dee-Zol Life extend the stored fuel life that I have, we would say, well, Dee-Zol Life under normal conditions can extend your stored fuel's life by at least 2x. The second question is, someone has fuel that's already gone bad, so to speak. It's already become unstable. It's already got heavy ends dropping out of it, and they need to know what to do about it. And so they come across, people talking about fuel stabilizers and how much benefit it has in that arena. And so they say, well, hey, what if I put a fuel stabilizer into my bad fuel? Will it fix it? Will it solve that problem? The answer, unfortunately for them, is unfortunately no. No, it will not fix it in the way that they're hoping it will. There's no feasible way to reverse fuel instability that has progressed to the point where the heavier constituents in the fuel are no longer soluble and are dropping out. There's nothing you can add to it that's really going to put those back exactly the way they were. And so that is why it's important to use fuel stabilizer and add it to the fuel at the beginning when the fuel is fresh. Once the damage is done, once these instability reactions have done their thing, you cannot put the genie back in the bottle, so to speak. Another question is how to use it. Of course, how do you best apply fuel stabilizer like Dee-Zol Life? Well, like any fuel stabilizer, like we were just saying, it has to be applied to the fuel when the fuel is fresh. It has to be applied before precursors have been allowed to form and before they have started to react with each other. So if you have a stabilizer present in the fuel before this happens, there's a lot less likelihood of them being able to happen because the stabilizer is going to neutralize them. The effectiveness of a fuel stabilizer also depends on proper mixing into the fuel. What we would say full integration of stabilizer into the fuel. That means you want to put it into the fuel and you want to get it really well mixed in there. Now, how you do that depends on what your capabilities are. Many large bulk users and industrial users have injection systems that they can inject a stabilizer into a fuel stream very easily. And for them, that is an excellent way to do it. Other people don't have anything like that. They might just have you may have a municipal police station with a backup generator and a 1,000-gallon fuel tank out back. They don't have an injection system. And so for those kind of cases, what we recommend is that they add stabilizer to the fuel and then they try to get some kind of circulation, at least get the fuel moving so that the stabilizer can get mixed in as well as possible. So those are the hows and the whys for diesel fuel stabilizers like Dee-Zol Life. Now, who would be the ideal users for fuel stabilizer treatments? Another way to put it would be to ask who are the recommended markets for fuel stabilizers and what are the problems that these markets typically face that could be solved by the use of fuel stabilizers. Well, the recommended markets would be anyone that relies on preserving the quality of stored fuel needs to consider the use of fuel stabilizers. So these kinds of markets would include, for example, number one market, municipalities and fleets. Municipalities and public, what we might say public fleets, but also private fleets, they store diesel for use in public fleets. They also store it for use in backup generator systems. And when that fuel becomes unstable, they're going to have problems. They're going to get drops in mileage and performance, which of course make their fuel budget expenses go up. They're going to have excessive emissions, which affects their emissions control systems and their service intervals adversely. They're going to get engine and injector deposits, which affect the performance of the equipment and engines over time, of course. They're going to get excessive sludge buildup in the storage tanks, and that's bad because that takes heating value out of the fuel. And a bunch of these play into this last one, which is uncertainty about the availability of their equipment. If you're talking about an emergency backup generator and you have unstable fuel that's not going to burn properly, then that fuel may not support the needed equipment operation at a critical time. And so, if you know that that's a possibility, then that creates uncertainty for you. And speaking of this kind of uncertainty, that is an even bigger concern for the mission-critical users and generator users. These rely heavily on backup fuel to help the equipment fire up and run in critical situations on demand. And so if you have unstable fuel, it creates the possibility that these critical systems will not function properly when needed, and that's a problem. Now, any questions on the availability and reliability of this equipment operation are then, by definition, integrally tied to the quality of the stored fuel that they rely on. So when considering these kinds of problems in the market, in these kinds of markets, the value of using a fuel stabilizer like Dee-Zol Life comes from the answer to asking the question what the potential costs of these problems are to these markets. It comes from accurately weighing the cost of preventive treatment versus the cost of dealing with the consequences of a stored fuel failure at a critical time. So with that in mind, that's the treatment on fuel stabilizers. The second arm of the fuel storage treatment suite that we move to are sludge dispersant and anti-corrosion fuel treatments for storage tanks. Now, to start this off, consider that there are thousands of fuel storage tanks out there, many of which have not been checked recently or are not checked on any kind of regular basis. Now, a typical storage tank may have stored fuel that's been in there for a really long time. And if it has, then it is very likely to have one or more of the kind of issues you see on your screen. Sludge buildup. As we've said before, you get sludge because of the stability degrading over time, and these heavy molecules forming, and becoming insoluble in the fuel and dropping out. So some of the problems if you get sludge buildup, the actual field level problems are going to be the same ones that we just talked about with respect to problems manifesting themselves in, say, equipment performance. If you get sludge buildup, it's going to make the equipment operate poorly or unreliably. It's going to plug filters, and it's going to take away heating value from the fuel because all of that sludge used to be molecules that are part of the fuel, and now they're not part of the fuel that's being burned, and so that takes away some of the heating value. Microbial biomass. When you get free water in storage tanks, you can get microbial growth established very easily and pretty quickly. One byproduct of microbial presence is that they form biomass growths. Biomass is a matrix of biological film, so to speak, that's produced by all sorts of microbial colonies. And biomass can cause a number of different problems. One of the things it does is, because it sticks to walls and surfaces, it can actually shield microbes from exposure to biocides. And microbes can actually live inside of the biomass as well. And so someone may recognize they have a microbial problem. They treat with biocide, but they don't get all of the microbes because they're being shielded by the biomass. And then, once that biocide has been used up and is ineffective, they can re-inoculate the tank. And biomass itself can also contribute to galvanic corrosion in the storage tank. Speaking of which, that's the last one, the third one on this, tank corrosion. When you get water, when you get microbes that are producing acids, and of course when you have galvanic corrosion happening because of biomass, well then, over time, you can develop serious corrosion damage in the tank. And not only does it damage the tank itself, which over time means you have to repair the tank, but it can contaminate fuel. Corrosion byproducts like rust can contaminate fuel, can plug filters, cause all sorts of problems. So, given all of these problems, it's obvious that we want to see what kind of solutions out there to help with these problems. And the solution that Bell Performance offers is trade name is Tank Treatment SDF. SDF stands for Sludge Dispersant Formula. And what it is a multifunction product that does, I want to say, three main things. It is a sludge dispersant, it is a corrosion inhibitor, and it also is a biomass dispersant. Now, it's one of the newer treatments that Bell Performance introduced in early 2015, and it was formulated in response to some of the microbial tank problems that we were seeing in our customer base out in the industry. Specifically, we had some municipal customers that had an experience where they had a fuel storage tank that had a microbial infestation. They treated it as recommended with biocide, which supposedly killed all the microbes in there. But then like a week later, they all came back. And so when they were, what everyone figured out happened was that they still had biomass in there that they hadn't done anything about, and they had re-inoculated the tank. And so Tank Treatment SDF was a stored fuel treatment that was formulated to solve that kind of problem. Now, it offers several big benefits to stored fuel users. Let's talk about some of those. First benefit, it absorbs and it disperses fuel sludge or tank sludge. When it comes in contact with petroleum sludge, it actually absorbs or disperses. Disperses is a better word. It disperses over time these heavy sludge molecules and essentially redisperses them back up into the fuel where they can be seamlessly combusted. So over time, when you have a tank that is filled with fuel that's treated with Tank Treatment SDF, over time that sludge presence in that tank is going to be significantly reduced, and it's going to be reduced everywhere that the treated fuel contacts, whether it's the storage tank itself, it's the fuel delivery lines, even the injection guns themselves. The second one is corrosion protection. Tank Treatment SDF utilizes an amide chemistry, which is similar to the filming amine chemistry that you may have heard referenced as a recommendation by the EPA. Functions in exactly the same way. It lays down a layer of protection on all of the tank surfaces that come in contact with the treated fuel, and it actually creates an anti-corrosion protective barrier. And this protection lasts as long as the treated fuel is in contact with surfaces. But it's a little bit different from some other things in that it does not actually chemically bond to the surface. And so if the fuel's not there anymore, it will go away. But if the fuel's not there anymore, there's less chance of it needing that protection. The third thing that it does is it disperses biomass. And as we have implied earlier, this makes biocides even more effective. When it comes in contact with biomass formations, it actually punches holes in them, and, for lack of a better way of describing it. It breaks them up, and it then enables biocide-treated fuel to then access the microbes that normally would be protected by them. And this is very important because if a customer finally reaches the point where they decide to use a biocide, they have expectations that it's going to solve their problem. And it's a pretty serious matter for them if they use a biocide and because of something like this, it doesn't work as well as they expected. That's a big problem. So using a biomass dispersant like Tank Treatment SDF can help solve this problem and can definitely significantly improve the efficacy of biocides. So all of these benefits add up to some significant benefits for stored fuel users. things like, they'll get cleaner storage tanks. Their fuel distribution system will be just cleaner overall with less tanks, with less sludge presence, of course, less biomass presence. They'll get their surfaces will be protected from tank corrosion, and of course, it's a key critical piece to protecting stored fuel from microbial contamination if you pair it with biocide use. So users of tank treatment SDF get all of these benefits. As far as how to use it so that it works the best, well, best practice recommendations for use. First thing is, for maximum effectiveness, it has to come in contact with the sludge or the biomass that's in the tanks. So therefore, like fuel stabilizers, it works best when it's well mixed into the fuel, and when it's allowed to come in contact with the aforementioned sludge for the longest period of time as possible. So ways to do this, there are good ways and there are better ways, and then there are best practice ways. Now, the two ones that you see there, the excellent ones, are addition with fuel circulation and direct injection into the bulk fuel stream. Again, depending on who you are, if you're able to do either one of those are the best ways to do it. However, not everybody has the ability to do that. So the next best would be, if you have a partially filled tank, you would treat, and then you would add fuel on top of it, and you get a splash blending effect. That's not quite as good as addition with fuel circulation or direct injection, but it's better than just adding it on top of the fuel and then doing nothing, which is the worst way to do it. I mean, if that was the only way, if addition to the fuel with just, simple diffusion, in other words, adding it on top and then just leaving it and letting it, just work its way through the fuel down to the bottom. If that really was the only way that you could add something like this, well, then you shouldn't let that keep you from choosing to use it, because having it in the fuel in that manner is going to be better than just not having it at all. But you definitely want to do your best, depending on your situation, to get it, to do whatever it takes to get it as well mixed into the fuel as possible, so that it will have the maximum residency time, maximum contact with the sludge and the biomass, and maximum effectiveness. Some common questions that people have when we talk about tank treatment SDF for their stored fuel. First one, they'd say, well, if I treat my fuel with SDF, tank treatment SDF, will it improve my mileage, or will it decrease it? Will it have any effect on that? And what we would say is that there can be some effect in mileage, but there's a specific reason why. The reason why is because if you take a heavy end molecule like sludge and you bring it back into the fuel to be burned, it will not burn quite as efficiently as virgin fuel would. And so just like when you're cleaning out a diesel vehicle engine and you're getting rid of those deposits, people who do that know that your mileage actually drops a small amount in the short term, but then as the engine gets cleaned, it actually recovers, and then it ends up increasing and staying at an increased level because the engine's cleaner. It's the same concept with this. As it's absorbing the sludge, you would expect a small drop in mileage for a temporary amount of time because it's cleaning all that stuff out of the tank. How much of a drop? Well, that's really situation dependent. Second question we have is, does it remove 100% of the sludge? They're especially interested in this in the Far East and in the Indian subcontinent, where we were asked this question. You would like to be able to tell someone that you guarantee that it will remove 100% of sludge, but that's a dangerous thing to do, because sludge is composed of a lot of different kinds of molecules, including a bunch of different versions of asphaltene composition. And not all asphaltenes are soluble in fuel, and adding tank treatment SDF is not going to make those insolubles soluble again. So it is going to clean up most of the sludge, but again, if you're being 100% honest, you don't want to oversell this to people. And if you're a customer that's listening to this, we're not going to oversell this to you because you want accurate information. And so what we would say is that tank treatment SDF removes most of the sludge. It won't get 100% of it simply because it's impossible for anything to remove 100% of the sludge into the fuel. Another question is, if they put it in fuel, will it change the color? The answer to that is that when you solubilize sludge like that, it does not actually substantially change the color of the fuel. Next question would be, next question for us, it would be, what are some of the possible markets that would benefit from or be interested in using tank treatment SDF? Well, you've got a lot of the same markets, a lot of overlap with the same markets that are interested in Belicide and DFS Plus and Dee-Zol Life, because they're all stored fuel treatments, and therefore any markets that use significant amount of stored fuel. So you're talking about, markets like mission critical systems, emergency generation systems, public and private fleets that store fuel. And what value propositions would there be for these kinds of markets? Well, they'd have benefits like they'd see less filter plugging, they would have fewer microbes in their stored fuel and in their tanks, they would have greater confidence that their fuel's condition is such that when they need it to work at a given time, it's going to do what they need it to do. That's very important. So that's tank treatment SDF. Sludge and biomass dispersant and anti-corrosion protection treatment for stored fuels. The third arm of the stored diesel treatment product group that Bell Performance has is our water controllers, water controlling treatment for stored fuel. Water is a universal issue for storage, or for fuel storage tanks. It's universally present in our environment. Virtually any storage tank you check that's been around for any amount of time will have some kind of water layer in it. How the water gets there, a number of different ways. It can get in there from air exchange through vented tanks, where water vapor in the air then reacts to temperature changes, condenses, and the water sinks to the bottom and builds up over a period of time. Doesn't take much temperature change to make that happen either. And you've got a lot of cases where people will just do stupid stuff, like they'll leave the lids off of tanks so that rainwater gets in. You have catch buckets that can hold anywhere from 5 to 25 gallons of water, and somebody who's making a fuel drop will open it up and to put fuel in. They don't care if the water's there. Boom, you've got just added 5 to 25 gallons of water right into that storage tank. And because water's heavier than petroleum, it always sinks to the bottom and collects and builds up as a layer of free water. Now, all petroleum has at least some amount of water content. It can exist in 3 forms. Dissolved water is the one that's the lowest level. It's dissolved, you can't see it. That's can be up to 25 to 50, in some cases, depending on the kind of fuel, as much as 100 to 200 ppm of dissolved water content. Then you have emulsified water, which is what you see in those 2 jars there. You see that cloudy, hazy fuel. That's emulsified water. And then when you get that layer of water that's built up on the bottom of the tank that we were just referring to, that's free water. Now, each of these forms of water needs to be handled in a different way. Free water can be mechanically removed from a fuel tank by just simple draining or mechanical pumping out. Dissolved and emulsified water, if you really have an incentive to get those out of the fuel, then what you're going to actually need is a demulsifier. A demulsifier actually breaks a fuel oil water emulsion, separates the water, and then enables it to drop out down to the bottom of the tank, where it can then be removed as free water. So water is important to deal with because it's associated with a number of different problems across multiple areas of fuel use. So what are those problems? Well, first thing is that water, we mentioned this earlier, water provides an essential medium for bacterial growth or microbial growth, not just bacterial, because you've got molds and fungus and yeast and eukaryotes, other things. But so it provides an essential medium for microbial growth. Microbes need the presence of water in order to grow and thrive, and typically they'll grow at the interface between the fuel layer and the water layer, and then they spread and they multiply and they produce acids and they produce biomass and they cause all sorts of problems. Second problem is water presence in fuel promotes the reactions that lead to oxidation and breakdown of the fuel stability. Third one is they cause problems with common rail diesel engines. Most of the diesel engines most of the newer diesel engines are common rail engine designs. Really, really high tech, much more efficient and more powerful than before. Really outstanding technology. Only downside is that they are extremely sensitive to water content. And so any water content in the fuel is going to cause problems for those kinds of engines. And we don't see that trend reversing anytime soon. If anything, it's just going to get worse and worse and worse, which means it's even more important now than ever before to stay on top of the water presence in stored fuel. So what will tank users commonly do to assess the condition or assess and then control the amount of water that's in their tanks? Depending on who you are, you may already be mandated to check your tanks for water at a specific interval, like once a month, once a quarter. Many people have to do that or have protocols in place that require that to happen. But for as many people who have this, there are just as many people in places who do not have any requirement like this. And thus those people many times end up with water buildup in their fuel storage tanks that's a lot more severe than even they anticipated. Now, they might say, well, I've got a water sensor. My tanks have water sensors. I don't need to go check my tanks. Well, water sensors are great. Vita root systems, things like that, those are great. But they are not always 100% accurate because they are pieces of machinery. They can get damaged. They can get corroded with vapor space and below the fuel line corrosion. So the recommendation is, use them as part of your protocol, but don't rely solely on them to be the only thing that you look at. Every so often, like once a month, you need to get out there and actually manually check for water by sticking the tank with water paste. You open up the tank, you take a tank stick, usually a tank measuring stick, put water paste down at the bottom, stick it down, leave it, changes color wherever there's water, like you can see in the picture, and then you've got an idea of how deep the water phase is. And if you've got a tank chart, like this one here, this is a 2,000-gallon convolt tank, and it tells you, a guy sticks his tank and he comes up with 3/4 of an inch. Well, 3/4 of an inch doesn't mean anything in and of itself. But according to the tank design, if it's a 2,000-gallon convolt tank, that means that he's got about 33 gallons of water in there. And so that gives him a quantified idea of how much water's in the tank. So all storage tanks have tank charts that you can use to determine the amount of volume water in the tank. If the water volume is too much, like if it's over 1/4 to 1/2 an inch, you would want to pump it out. If it's closer to a trace amount, or you do a manual removal of it, many times you cannot get all of the water out there. That is when you would consider using something like this, a chemical water absorber like DFS Plus from Bell Performance. DFS Plus was developed by Bell back around 2007 as a single-function water dispersant formula. And it's unique in our product line because it actually acts as a water absorber. It absorbs or dissolves water into the fuel, as opposed to dispersing water up into the fuel like our traditional fluorosurfactant chemistry for many years would do. Once DFS Plus is mixed into the fuel and comes in contact with free water, it grabs hold of the water and it absorbs it and disperses it into the fuel such that you cannot see it in the fuel and you cannot see the water anymore. The DFS Plus formula itself is would be classified chemically as a surfactant. Basically, it has one end that is hydrophilic and one end that's hydrophobic. In other words, one end that is attracted to water, and one end that is attracted to things like fuel, hydrocarbons. And so it grabs the water, bonds it into the fuel. Once bonded, the water will never drop out of the fuel. And so, if you use DFS Plus as part of a stored fuel treatment regimen, what kind of benefits will you get? Well, apart from helping you to clean up trace amounts of water that you can't get to by conventional methods, you'll get benefits like, first of all, reduced ability for microbes to grow. Now, this is something that we have to comment on here. What we're specifically saying there is reduced ability for microbes to grow. In other words, removing the water reduces microbial ability to grow in a storage tank. Now, contrast that with the claim of something called a biocide. Biocide says kills microbes in stored fuel. There's a difference between those two kinds of claims. One of them, the second one we just said, kills microbes. That's a biocide claim. That is a legally valid biocide claim if the substance in question has been registered as a biocide. On the other hand, what we said before reduces the ability for microbes to grow. That's not a biocide claim. That is the claim of a biostat. A biostat is contrasted with a biocide in that a biostat does not kill microbes. It simply makes it more difficult, makes the conditions more difficult for them to grow. And there's a legal distinction between those two things because one of the things you see out there in the marketplace is you see a lot of different kinds of fuel additives out there. Many of them have water control components to them, but they're running around making or implying biocide claims, implying that if you remove the water, you'll kill the microbes. That's absolutely, positively not the way it works. And that is not what DFS Plus does. Bell Performance has a biocide called Belicide, which, as I said at the very start, is something we cover in a lot more detail in other trainings. So DFS Plus, it has a biostat ability to reduce the ability for microbes to grow because it controls the water. So it doesn't kill microbes, makes it more difficult for them to grow. Also, second one there, tank corrosion control. Because you're controlling the water, water is one of the key elements of storage tank corrosion, so you will have a meaningful effect in that area as well. And if you're controlling the water, you're also helping to control any water-related fuel instability. Base treat rate for DFS Plus, typically 1 to 1,000. Sometimes it's higher, sometimes it's lower. It really depends on the amount of water that's present in the tank. Again, really effective water control treatment is as much an art as it is a science. But the baseline treat rate for DFS Plus for stored fuels is about 1 to 1,000. Tanks with higher amounts of water may need to use more. But again, remember that the primary thing that you're going to be doing when you're remediating aerating your stored fuel tank is you're going to mechanically pump out the water to begin with, because that's always going to be the most cost-effective thing for you to do, is get rid of as much of the water as possible through mechanical means, and then use a chemical water controller like DFS Plus to clean up what you can't remove otherwise. Now, DFS Plus, like the sludge dispersant tank treatment SDF, it only works when it comes in contact with its target. In this case, only works when it comes in contact with water. Therefore, it is important to get it well mixed into the fuel so that it can do that. And so the application methods that you see are exactly the same ones we were talking before. Direct injection to bulk fuel tanks, excellent. Addition to fuel and then with circulation, that's better, although you need to be careful not to over-circulate the fuel, because you don't want to emulsify any excess water that's in there that the DFS hasn't controlled. Addition to the fuel, in a partially filled tank before, and then adding new fuel on top, that's decent. And then, just like we were saying with tank treatment SDF, adding it on top of the fuel and leaving it to diffuse is not the recommended way to do it, but it would be better than not using it at all. But really, you want to do your best to try and do something like fuel circulation or splash blending or something to get it mixed in there. But if you have to just diffuse it, well then, you got to do what you got to do. So common questions that we get, frequently asked questions about the DFS Plus formulation. First one, how much water can it control? Well, a good rule of thumb is 2 parts, about 1.5 to 2 parts of water for every 1 part of product. If you were able to calculate how much water was in your tank after you mechanically removed it, then you could really dial in your treat rate. But as a general rule of thumb, 2 parts, 1.5 to 2 parts of water for each part DFS is a good ratio. What factors can influence this treat rate? Well, again, when you're out in the real world, things are rarely cut and dried, like 2 parts water, 1 part product in every single kind of situation. There are other things that influence that. The amount of fuel that's in the tank. Larger amounts of fuel may need more because they have a larger amount of solvent, if you will, fuel, for it to work its way through. The amount of circulation time, the amount of residency time that it has in the tank. Those are factors that will affect how much DFS Plus, how much water dispersant you really need to use. How does DFS as a single function product compare to other Bell formulations? First thing, as we see on the screen, DFS Plus was formulated as a single function water controlling product. Some of our other formulations like Dee-Zol and like Mixago, which predated DFS Plus, those had water control components included in the formulation as part of a multifunction product. Dee-Zol and Mixago are awesome multifunction formulations that do a lot of different things. They provide detergency. Dee-Zol provides cetane. They provide lubrication. They provide fuel stability. They provide all those things, and they have traditionally offered a water control component, but it is a different kind of water control component. It's not a water absorber or dispersant in the sense that of the active ingredient in DFS. It's actually non-alcoholic fluorosurfactant, and what that does is actually take water and take form really small micro-sized micelles, and then actually suspend that into the fuel. So DFS Plus does differ from those products, and because DFS is a single function product, that's why we include it in the stored fuel product suite, so to speak, and not one of these other multifunction products. if you apply DFS Plus to the fuel and it absorbs the water, so you've now got treated fuel that has water that's controlled, absorbed back into phase with it, and you run that through a coalescing filter or a fuel water separator, will it separate that out? The answer is no. Any water that's treated with DFS Plus, treated in the fuel with DFS Plus, will not be filtered out by typical fuel water coalescing filters. Can you use DFS Plus alongside other fuel additives? This is one that we get a lot with a number of other fuel additives or fuel treatments that we have. It's what they're really asking about is compatibility. They say, they say, well, I already have this in my fuel. If I add DFS or if I add tank treatment SDF or if I add Dee-Zol Life, whatever, is it going to cause problems? And the important thing to know, and this can be applied to any other fuel treatment out there, not just the Bell Performance fuel storage treatments, but any other ones. By and large, for the most part, they're all compatible with each other. Now, we haven't tested every single one of the thousands of them out there, but just from what we know about the chemistry of the kinds of things that are used out there in the marketplace, they're all compatible with each other in that they won't tend to cause problems, at least not the aftermarket kind that consumers have access to. So, pretty much it's going to be really difficult for anybody that's outside of, let's say, the refinery level to find a couple of fuel additives or chemical fuel treatments that would cause problems with each other if they were used alongside each other. So the answer to this is yes. You can use DFS Plus, you can use tank treatment SDF, you can use Belicide, you can use Dee-Zol Life, Dee-Zol, you can, any of those in the approved fuel for its use can be used alongside just about any other kind of approved fuel additive that's out there. Recommended markets for DFS Plus, again, because this is in the stored fuel stored fuel treatment suite, it's the same kinds of people. So you're talking about emergency backup generators, you're talking about mission critical entities, government entities, marine environments because they're in a high water environment, of course. Anyone who has stored fuel will be an appropriate market for DFS Plus. So the Bell Performance stored fuel treatment suite of solutions. Dee-Zol Life for fuel storage, fuel stabilization, used at a 1 to 2,000 treat ratio, contains the optimal combination of stability ingredients, antiperoxidals, dispersants, acid-base neutralizers, so that it will extend the storage life of stored fuel. That's product number one. Product number two, tank treatment SDF, sludge dispersant, corrosion protection, and biomass breakup treatment. Used alongside a biocide, it really increases its efficacy. It's a very valuable tool to keep storage tanks clean, keep microbes under control, and reduce filter plugging. And tank corrosion. And then this last one, DFS Plus, single function water controller, controls water differently than other types of surfactant chemistries, appropriate for any user who relies on stored fuel quality, wants to reduce the chances of microbial action developing in their tank, wants to reduce storage tank corrosion associated with water buildup. Anybody who wants to protect their stored fuel really should consider all three of these stored fuel solutions from Bell Performance. So Dee-Zol Life, tank treatment SDF, DFS Plus, used individually or better yet, used together, represent a complete stored fuel solution package. We hope that we've been able to answer all the questions that you might have about this. And so if you have any questions, definitely contact me here at Bell Performance. My name is Eric Bjornstad. I'm Technical Information Director. So again, thanks for joining me. Hope we were able to answer some of these questions. that brings us to the end of our time together. Thanks for joining me, and we'll see you next time. Bye.